Today we are going to learn about algebraic reasoning rules. Please pull out this note sheet titled Algebraic Relationships Rules. We have a couple of definitions to start with. Our first definition says a list of numbers in a specific order. This is called a sequence. Our next definition is each number in this list of sequence. So each number in a list of sequence is called a term. And then we are going to learn about two sequences. The first one can be found by adding the same number to the previous term. This is called, just like it sounds in its definition, an additive sequence. Our next sequence is found by multiplying the previous term by the same number every time. In multiplying, it is called a multiplicative sequence. And those are our 4 new vocabulary words for this lesson. So let's compare an additive sequence and a multiplicative sequence. We notice we started out with the first numbers in both sequences, a 1 and a 3. The difference here is that whenever we go from 1 to 3, we are adding 3. When we go from 3 to 6, again, that is adding 3. And from 6 to 9, adding 3. So that is why it is additive. If we go for our multiplicative sequence, when we go from 1 to 3, we could say we add 3. But when we go from 3 to 9, we cannot add 3. That would be 6. So that automatically rules out our additive sequence. And then we try multiplying. 1 times 3 is 3. And then when we go from 3 to 9, we see if we multiply the previous term by 3, do we get 9? So is 3 times 3 9? Yes. Now we need to multiply the previous term, which is 9, to get to 27. Is 9 times 3 27? It is. So this is a multiplicative sequence. Now let's practice this. Determine the relationship between the terms. So problem number 1 says, describe the relationship between the terms in this additive sequence. So right away we know that we are going to add between our terms. We have 7, 14, 21, and 28 in our sequence. So 7 plus 7 is 14. 14 plus 7 is 21, and 21 plus 7 is 28. It wants us to find the next 3 terms. So that means that we take the last term of 28 and we're going to add 7. 28 plus 7 is 35. Then that's our next term. Then we are going to take 35 and add 7. 35 plus 7 gives us 42, which is our next term. Our rule states to take the previous term and add the same number, which is 7. 42 plus 7 is 49, and that is our third term that we found. So each term is found by adding 7 to the previous term. Let's try this again. Describe the relationship between the terms in this multiplicative sequence. So we have multiplicative. That means that we are going to multiply. So let's look at our sequence. We have a 2 and a 4. How do we get 2 from 2 to 4? That's multiplying by 2. Let's see if this works. 4 times 2 is 8, and 8 times 2 is 16. It wants us to write the next 3 terms. So that means we're going to take our last term, 16, and multiply that by 2, which gives us 32. So that's our next term. We're going to take 32, and we're going to multiply it by that same number 2, which gives us 64. That's our next term. We're going to take our last term of 64 and multiply it by the same number, 64 times 2, 128. So our last term we had to find was 128. So each term is found by multiplying the previous term by 2. Even though each term can be found by adding the previous term, the sequence is not additive because the difference in each term is not the same. So that means if we have a sequence of 1, 4, 8, and 16, if I go from 4 to 8, I'm adding the previous term. 4 plus 4 is 8. And then if I go from 8 to 16 and add the previous term, 8 plus 8 is 16. However, if we notice down here, the difference between the terms are not the same. Therefore, it is not an additive sequence. Now determine if the following is additive or multiplicative. Also, find the next two terms. So we need to see the relationship. We have 0 to 15, we have 15 to 30, and we have 30 to 45. I would like to see, how do I get from 0 to 15? Well, that's by adding 15. I cannot multiply 0 by anything to get to 15 because anything times 0 is 0. Therefore, this is going to be an additive. Let's double check. That means that if I take 15 plus 15, I do get 30. And if I take 30 plus 15, I do get 45. Now, please find the next two terms on your own. And we will check tomorrow. This one is the same thing. I want you to determine whether it's multiplicative or if it's additive. So you need to find the relationship between the terms. I would like you again to try this one on your own, and you will check with your group tomorrow. A sequence can also be shown in a table. The table gives both the position of each term in the list and the value. So if we look at our list form, this is the first number, therefore it's position 1. Second number, position 2. So whenever we take our list and put it in a table, we list the positions. And then the positions happen to be our x, and the value of the term, meaning in position 1, we have a value of 8. That is our y. So these are two different ways to see the same set of numbers. So let's look at our position and let's look at our chart, or our table. It says use words and symbols to describe the value of each term in relation to its position. Then find the value of the nth term. Should be nth term. For this particular problem, I'm going to have you change the value of the terms. So in position 1, instead of having an 8, we are going to have a 3. In position 2, instead of having a 16, we are going to have a 6. In position 3, instead of 24, we're going to have a 9. And in position 4, instead of a 32, we're going to have a 12. And then we'll still have a box for our nth term because we're going to learn how to find that. Okay? So in position 1, I have a 3. So what we're going to do is we're going to take our position and we're going to multiply by 3. So that means that our rule is x times 3. Okay, so that rule is 3x. Okay, so 1 times 3 is 3. That's our value of our term y. So position 2, we have a 2. Multiply it by 3. That is our 6. We do the same thing, take our position, and that which is our x term, and we're going to multiply it by 3, which gives us a 9 for our y term. Remember, position is x, value is y. So we take our position of x, we multiply it by 3, which gives us 12. Now here we have an n term. This is our nth term. We want to write our rule. What is our rule for our nth term? Well, our variable is n. That's what's in our position. So we have an n, and our rule is to multiply by 3. So we get n times 3. The value of the term we are unsure of, so now we just take this, and our value of our term is the product of 3n. Let's put that to practice one more time. Here we have our position, which is our x value, and we have our value of terms, which is our y value. So if you notice, our positions are all labeled right here. And here is our rule, add by 4. That means that we're going to take x and we're going to add 4 to x to get the value of our term, to get our y. So if we have a 3, we have a 3 plus 4, which is 7. If we notice, we have a 3 and a 7. We have a 4 plus 4, which is 8. When we have a position of 4, we have a value of 8. I would like you to try to figure this out on your own, the rest of the table. Fill out the value of the nth term. So whatever you get in this box, you're going to place here. And then plug in the number 8. So you can add an extra row, and here you're going to have an 8. And find the value of that. Once you finish, you may complete your summary questions. There are 3 questions. Please write in complete sentences, and we will go over this tomorrow.